Hi everyone, my name is Thomas Kim. Today is May 20th, 2019. This is my 16th episode about the future of C++ programming, C++ 2A standard. This is my fourth episode about threading. In this episode, we will learn about Init Capture or initialization capture for Lambda for inter-thread communication. When our algorithm is more complex, using C++ standard parallel algorithm or OPENMP or Microsoft's parallel pattern library or Intel's threading building block can be a challenge. In such cases, we can use Init Capture for Lambda with specifier mutable to parallelize our algorithm. Init Capture for Lambda was introduced to C++ 14 standard. We will also learn how to create multiple threads dynamically at runtime. We will also learn how to maintain constant number of threads while our thread functions run. This technique is not difficult but rather new to the most C++ programmers. More specifically, we will learn Init Capture, this syntax. Especially, we will learn about this syntax. This is working draft standard for programming language C++, February 12, 2018. Or you can click this link from creference.com. We will be using this syntax. It was introduced to C++ 14 standard. In future sessions, I will talk more about C++ Lambda expression. I highly recommend you watch this video, Last Resort Multithread Recursion. Please double click this link. If you haven't tried Recursion with multithreads, I highly recommend you to watch this video to follow this session. If you watch this video, you can understand fundamentals about how to use multithreading for recursive function calls. Also, in this series of videos, I would like to recommend you to watch this video, Thread Function Episode 10. Also this video, Inter-Thread Communication Episode 11. You also need to watch this video, Enumerate Permutation Theory 1, and the most important yet least understood concept in C++ language. Double click this link. From this episode, Show More. Click this button to download source code because we'll be using this source code from this episode. Also, we'll be using extension talkplayfun.com from this website. Download latest source code. If you haven't set your system environment variable, please click this link and make correct system environment variable settings. Otherwise, you cannot follow this episode. Click Show in Folder, unzip this file, also unzip this file. From Exception Safe, right click, cut, CPP Extension, tutorial, paste, like this. Then right click, CPP Extension, copy, and paste it to your working folder. Okay. I will copy this file, copy, and paste it to my working folder. Right click, paste. You have to do this in tutorial folder. Ctrl C, copy the folder path. Right click your command prompt. Right click once again. Properties. Start in field. Ctrl A, Ctrl V. Click OK. Okay. Select CPP extension. Copy the folder path. Start your Visual Studio Code. Go to File. Open folder. Paste it here. Select folder. Then open it. In my case, I will select root folder. Select folder. In your case, you can find CPP extension is root. In your case, select tutorial. Click this button. O16 parallel permutation.cpp. Double click exception save CPP file. Ctrl A, Ctrl C. Paste in this file. Now close exception saved CPP. Ctrl B, Ctrl plus. Scroll up. We will delete this part. Include talk play fun. Set HPP. Include talk play fun. Chrono random HPP. Include talk play fun. NCR NPR HPP. Include talk play fun. Output HPP. Namespace. Types. Talk play fun. Types. Namespace. Set. Talk play fun. Set. Namespace. CRS means chrono random stopwatch. Talk play fun. Chrono random. Namespace. CPR. Combination, permutation, routines. I will just use like that. Talk play fun. NCR, NPR. Talk play fun. SS stream. Now we will remove these two parts. I will remove this part like this. Then I will introduce template, type name, class, container type. I will change it ELE type. Then type name, types, type name, outer type. Now here it should be container type, container type, ELE type, types. Outer types. it should be types like this. Container type, yearly type, types L. I will also modify this part. Container type, yearly type, types like this. Okay. Then scroll down, scroll down, scroll down. We don't need this part, so I will delete it. I delete it. I will modify like this. I will clean up some code. Like this. And we don't need this. I will arrange like this. Now scroll down. We will remove this message. And we will also remove it. So we made a lot of changes. I will delete this function and introduce a new function. Template, type name, and type. Type name, alt type. Or build permutations and type and alt type R. Using element T, we will use the short. Using container T, std, vector. We will use vector as our container. Using set tag, talk play fun, set tag. We have to provide a container type, then element type. Using set T, we define set, talk play fun, set T, we have to provide a set tag. Using set T, talk play fun, set T, set tag. I will talk more about these things in some future sessions. Now we define set TL, we resolve L n elements, then we initialize for size ti equals 0, I less than size t n plus I, L implies spec. We can use algorithm, but I will just do this. Element T I. We initialized set L, then set T R, we resolve R, N, like this. Now we create set of sets, set T permutations. Okay, now we call this function like this. The first is permutations, then L, R, return permutations. We set it to auto. Okay, I don't think we need R, so I will change an R type. I will simplify it, and I think I can remove this. So an R type. Okay, and I will modify the namespace here. I will say tutorial video, namespace tutorial video top, and here end over namespace top or tutorial video. I say tube, tub, tutorial video. With this, we are going to introduce some function in global scope. Void test build permutations. INTN. Okay. CRS chrono random stopwatch. I will create SW auto permu CPR. This is combination permutation routine. Here NPR N. It is actually N factorial. I will copy this and paste it here. Stream generating permutations. Talk play fun and there. Now we start from here. Auto permutations. We call this function copy, paste. Its namespace is TUV tutorial video permutations N. We are calling this function, and this function returns permutation. Now we display the permutation like this. For auto P permutations stream P talk play fun and L. We have to flush talk play fun flush like this. If we don't flush, we cannot see the result. Now we are calling this function, copied, pasted it here. Then here, int argc character argb. Okay. If argc greater than 1, it means 2 or more. Command line arguments. Else stream ucg argb 0 n toggle fun and there. Here auto n equals atoi argb 1. So we can do like this. N. Okay. I have to fix like this. Now start your command prompt. cls dir o16 cl ehsc std c++17 o2 empty is for multiple threading library. o16 parallel permutation CPP FE AEXE 31 it is ELE type. Now let's build once again. CLS A, so A 4, so 0 1 2 3 24 permutations are generated in dictionary order. These are in dictionary order generated. I forgot to display time here. Stream elapsed SW elapsed time chrono random stopwatch second T. We can change the unit of time like this. Then it should be talk play fun and there. I fixed like this. Now let's compile once again. Here I will change it to MD, dynamic multithreading DLL, and hit enter. CLS A 5. So 5 factorials are displayed like this. This is elapsed time is 0 some seconds. Okay, so we will change it into huge number. Now you understand how to use this function. Now I will copy the whole part from here. I will copy the whole part up to build permutation right before end of namespace, copied, and I make some demarcation, paste. In real application, we actually don't do this. Okay, instead of doing this, here I will introduce another type name, callback type. Okay, then here I will pass callback type, callback, callback. Okay, I introduced another parameter here. Instead of doing this, we can call like this, and I will remove this container. I removed this container, and we don't need auto type. I will delete this part too. Like this. This is callback function. Callback function. Okay. Here, instead of doing this, we can remove this callback R. Okay. We modified like this, and let's keep going. Here, we don't return. I will modify into void type name, callback type, callback type, callback. I modified like this, and we don't need this. I will delete it. Also, std forward callback type, callback, and I delete this part. We don't need to return. Now I have to make more changes here. std forward callback type, callback, and okay, we fixed like this. Now I copy this function once again. See, performance test. I modified like this. Now we don't need to display. Delete this part, and I will copy. We don't need this. Simply calling this is okay. Or callback, or p. Here we will catch stream. No, we can't catch stream like that. Talk play fun, ss stream output, and I will put it here. We are passing as a reference. Then output p talk play fun end line. I will do like this. Then we pass this callback like this. Okay. Then I put message stream generating permutations in sequence. Talk play fun and there. Now we call this function copy and paste it here. And I disable it. Now let's run. Okay, CLS A5. It runs exactly the same as before. Okay, it runs exactly the same as before, but it takes more time because we are using callback functions. Now we remove this message, then we can achieve better performance. It took 0.1. We rebuild. Now A5, it takes this time. Okay, it actually executes all functions, but it only does not display. It can go more operations here. More real code based on permutation P. Okay. Now we can test with 10 factorial. This is 10 factorial. So we are enumerating 3 million permutations. It took 1.8 seconds. 11 factorial is now 39, almost 40 million permutations in sequence, not using parallel code. It took 19 seconds. Now we convert it into parallel code. Okay, so we copy this code once again, then we modify parallel code. I will copy from here up to this point. Going parallel. I paste. We will convert it into parallel code. Before we convert it into parallel code, I will create some type here. Struct thread bundle int max threads. Okay, std atomic int thread count. Okay, I say current thread count, and I will say max thread count. This will be used for read only, so we do not safeguard this variable. This variable will be shared among threads. So we have to safeguard from help read. So I created the thread bundle. I copied from here. Going parallel here, I will add it, and it should be modifiable TB. Okay, I added it. I copy it once again. No. Here, TB, copy TB, and we have to put it here too, like this. It is recursive, it is calling itself, and here we will create TB thread bundle TB, and we also have to pass this TB to here, like this, and performance test here, template, type name, thread vector type, copy here, vector. Okay, in this function we will create TB here, thread bundle TB std thread hardware concurrency times vector. Okay, I forgot one thing. We also need mutex, std mutex to synchronize stream console output. Okay, then here we will also capture TB like this, and if we want to display std unique log std mutex log tv mutex. Okay. Now I will copy this once again, paste, generating permutations in parallel. Okay, I modify like this, and we have to pass TV. Okay, now let's build and run. This is not yet completed, but we can test if it runs. Let's try to build. Okay, we have to pass factor. It will be 2. I have to fix like this. Auto factor ATOI ARGB 1. Okay, and we have to increase 2. Then here factor like this. Now let's build once again. CLS thread bundle undefined 263 This is TUV tutorial video. Okay, and I will also modify here factor n. I will copy once again. Factor is for hardware thread multiplier, and I will copy once again. And for factorial size. Now let's compile once again. 263. I will say it int, and okay, let's build once again. Okay, it compiles successfully. Now scroll up, going to parallel here. I will define using set t, and I copy this name, paste it here. Please note that this enum function returns void, so scroll down. We need to parallelize this part. Okay, here outside of the for loop, using future t std future void because this enum permu does not return using futures t. It is plural form std vector future t. Okay, we create futures t futures. This is equivalent to std vector std future void like this. Okay, then we are going to parallelize this part. If the size means this size, okay, else size is less than 7 or TB current thread count greater than or equal to TB max thread count. Okay, then we do not create thread, else here in this block we create multiple thread. Or go parallel, we need to capture TV and we have to copy L like this, just L. Okay, set T, we copy this L. This is initialization list, and R, set T, we are copying this R like this. We captured L and R TB, then we call this function again. TB L R. So we are creating a capture. Then futures, this is future vector, this vector in place back std async std launch async go parallel. So we are passing this capture to create a synchronous call for this enum permute. Okay, then we increase thread count, TB current thread count. Okay, please note that we are in for block. Okay, we are in for block. After for block, for auto app futures. Okay, now wait app wait, then we decrease TB current thread count. Okay, so we are in else like this. If we compile it, it does not compile. Okay, because this is initializer list. Okay, we have to copy L and R like this. If we compile it, it does not compile. No, it does not compile. Okay, by default this is created as this initializer Init Capture is created as constant, or this lambda is called constant. So we have to make it mutable. Okay, if we don't put mutable, these L and R are captured as reference. Okay, these are captured as reference. They cannot be changed, so we have to set it mutable. Now let's build once again. CLS. I will try once again. Term does not evaluate to function taking one argument. Sorry, this is different callback. This callback is for parallel case, and we have to create another callback. I say callback parallel, and another one callbacks in sequential. Okay, in this case we don't need this, and I will disable it. So when it passes, it should be callback parallel. In this case, callback sequential. Okay, now let's compile once again. CLS callback, we capture callback, copy and paste like this. Now let's compile, hit enter. Okay, it built. CLS A 1 3. So it is in parallel algorithm. 0 1 2 0 2 1, it goes parallel. In this case, this is serial. Okay, now if we want to display thread ID also, then we can display thread ID like this. Here we will display thread ID 2, std, this thread get ID. We can display thread IDs along, and also here stream using vector times std thread hardware concurrency. Threads. And there. Now let's build once again. 우리 talk play fun and hit enter. CLS A 1 5. Okay, we have this result generating 120 permutations using 4 threads. Okay, this is in parallel mode. This is in serial mode. I will make a few more changes. I will copy this part. Also paste it here. And here. If P size less than 6, then we display the contents. Okay. When the permutation is less than 5, the element is less than 5, then we display. Otherwise, we don't. I will copy this, copy, paste it here. I can remove this part. Now we build once again. A 1 5. So when element count is less than in our code here, if the size is less than 7, that means 6 to 1, 2, 3, 4, 5, 6 up to 6, it is running in serial mode, in sequential mode. If it is greater than 7, then it goes. If this is false, then it creates multiple thread like this. Okay. Now we try huge number 10. We will use 20, 10. So it is computing 3 million permutations. When we use in parallel, it takes 0.9, almost 1 second. In sequential mode, it takes 1.28, this is almost twice faster. Parallel mode is twice faster. Now we are going 11 factorial. Now 39, almost 40 million permutation in parallel. It took almost 10 seconds in parallel mode. Now it's in sequential mode. In case of sequential mode, in sequence it takes 20 seconds. Okay, so parallel mode is twice faster than sequential mode because I have 2 core on my machine. Now let's try with 12 factorial. So we are using 80 threads, okay? Because I have 2 core, 4 hyperthreads. So total 80 software threads. Now we are computing 479, almost 480 million permutations in parallel. In future sessions, I will deal more advanced parallel and multi-threading algorithm. Please subscribe to my YouTube channel. Thank you for watching.